example to like use. So the one thing I can safely say is with functions, right, and inverse in particular, because you can see that's what is being dealt with here. You see inverse, 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 inverse. And then here they're talking about, they give us a function f of x, right? And then here they are specifically giving us a domain to work with. They're asking us to work with the domain where x is bigger than 0. Now, the main reason behind inverse functions and them giving us a domain to work with, especially with the parabola, is that when you deal with functions, right? Or when you deal with graphs, rather. Let's draw a graph here. Let's draw a parabola like this. And as mentioned or not, but we'll mention it now, with your inverse functions in grade 12, right? You always work with like the really basic ones. So the inverse of this graph, right, will look something like, let me just draw the line of inverse first. So the line of inverse will be this line, right? This is the line y is equal to x. And yes, it will always just be this line, y is equal to x. It won't be any other line. So the inverse of this graph, it will need to be a reflection about this line here, you see. So the easiest way to be able to see what the inverse looks like is, remember, this is more like a mirror image, meaning on this side of your line, you should have whatever you're having here, you know. And then if you're having something here, you should have it on that side also. So already, if you're seeing there's like a curve here, right, on the bottom side of the line, you already know that you should have a curve on the other side like that, see, because these should always be, this should be like a mirror image of itself. And then here, if you're seeing that you have this curve going out like that, automatically you know you should have one going this way, you see, because these should be mirror images of each other. Furthermore, what you know is, you see here, if you have, let's say, this arrow up there like this, you see, you know that you should have one down here, you see, somewhere over here, you see. So that's how you know, okay, your inverse looks something like this. Now, you knowing that your inverse looks something like this, the issue is this inverse, right, is not a function. It's a graph, yes, but it is not a function. The reason it's not a function is the easiest question and the easiest answer, I see. This is not a function because of the following. This is not a function because, and this is something you can use in an exam, and it's 100% what you call recognizable. So it is not a function because it fails the vertical line test. So the vertical line test is basically you're drawing a straight line going downwards. If that straight line cuts the graph once, it's a function. That's why the yellow graph is a function, because it passes the vertical line test. The green one, it fails the vertical line test, you see, because the red line touches it twice, you see. So this here is not a function because it fails the vertical line test. So let me maybe just label it so that it is clear, right? This is like the inverse of f, and then this one, we could basically look at it as f, you see. So the idea is, because the inverse of our graph here is not a function, the idea is there is something we can do to the original graph to make sure that its inverse is a function. Let me write that down in words so that it can always stick. So let me put here, there, or rather, let me ask it as the question they normally ask. So normally they'll ask something like, okay, is whatever you are dealing with a function? Then you either say yes or no. Normally, if it's not a function, the follow-up question will be asking you, what can be done to make the inverse a function? And the answer is simple. It's always going to be the same answer all the time. The answer is restrict the domain of f of x to x is It doesn't matter. You restrict the domain to x is bigger or equal to 0, or x is smaller or equal to 0. What that means is, let's use the first option here. Let's underline it in blue. If you restrict the domain of the original graph to this, what that means is, in your image, right? This is your original graph, right? It looks like this. Now, what you know is that this is positive x values, these are negative x values. So this is saying if you restrict your domain to where x is bigger or equal to 0, you are only going to be considering this portion of your picture. You see, what that means is, instead of you drawing the whole thing, you will only be drawing the portion where your x values are bigger or equal to 0, meaning this goes away. This part here goes away. Now, this is what you will be looking at. Now, what that says is that automatically, if you're just looking at this picture here, this picture will always have an inverse that's a function. Because when you will now draw the inverse of this small picture, you are only going to draw a picture that looks like this. You see, so you see you have this curve down here. It's on one side of your line of inverse. So automatically you should expect another one like there, you see. And then already you can see that, okay, if you have one here that stretches going out like that, this one is going to go like this, and it's obviously going to stretch out like that, you see. So you have restricted the domain to x is bigger than 0. You see, that's one option to making sure that your inverse is a function. The other option is if you restrict it to x being smaller or equal to 0, if you just only consider the domain where your x values are smaller or equal to 0. So if you do that, you're going to have, instead of you having a full image like this, right, you are only going to have, you're only going to be seeing the parts where your x values are smaller or equal to 0, meaning this you won't be seeing it. See, this you won't be seeing it, and then this is the only thing you will see. And automatically, if you are only seeing that, your line of inverse is here. Meaning, if you're going to draw the inverse of your graph here, right, you can already see, okay, this curve is going like that. So if this is your line of inverse, you already know that, okay, fine, whatever you're seeing there, you should see it on the other side somewhere here. Because remember, these have to be reflections of each other about this line. So if you have a line there, right, if you have a point or arrow there, your other arrow, you know it's going to be like somewhere over there.
Yeah.
And then you know your curve looks like that. You see. So this is the inverse. This is the inverse. And then we know that this would have been the original graph. And then we know that this would have been the original graph. You see, it's a matter of choosing one of these, because you obviously can't have both. Because if you have both, you have a full graph, of which that will mean that your inverse won't be a function. So if you look at what you have now, your inverse is now passing the vertical line test. Because you see, your inverse graph, it's only going to be touched once. Your original graph also only going to be touched once, because it's two different graphs, you see. It touches the inverse once here, it touches the original graph once there. So they are both functions, you see. This touches it once, this touches it once. So you see, now you know that the inverse passes the, let me write it a bit apart so that doesn't look like it's there. Passes the vertical line test. You see, so when we say it passes the vertical line test, what we're referring to is how we have just restricted it to one domain. And that's the whole essence of questions like these, right? If they are telling you something like this, they're trying to tell you that, okay, you're only going to be, let's see, x is bigger than 0, right? You're only going to be dealing with one half of the graph. And if you deal with one half of the graph, you're going to deal with one half of the inverse, of which the inverse will be a function. Cool.
Cool.
Yeah.
And then when you do the inverse, right, you just swap the coordinates around.
Yes, 100%. 100%. Now, with sketches like these, right, what we can also remember is that if you do have, let's say, a negative parabola, you see, a negative parabola will look like this, but then its inverse will go to the other side. You see?
Yeah.
So you want to remember that if you are only dealing with, let's say, one portion of this sketch here, say you're only dealing with the right hand side like that, you see, your line of inverse should always help you to see what your other
Side
what
will
you
be.
call your other sign, what your other graph will look like. So let me maybe do this here. Trying to oopsie. So I'm just trying to draw this a bit nicer like that. See, so if this is your line of inverse, right? Your line of inverse looks like this. So automatically, if you want to draw the inverse of this graph, you already want to think, okay, fine, there's this tiny part here on the one side, so you're gonna have a tiny part here as well, you see.
That's a nice way of thinking of it. I never thought of it like that.
Yeah, because that's the inverse. It's just supposed to be mirroring each other. So automatically you can see the curve is guiding you to say that this part carries on like that, you see. And then already you can already see, okay, wait a minute, if we had, let's say, the other version, the one where we have the other side like this, if we had this, also nothing changes there. We still have what you may call our line of inverse here, and then our line of inverse is going to guide us to say, okay, wait a minute, we have the image like that, right? So if you have, let's say, a point here, you want to remember whatever this distance is, right, going this way downwards, it should be the same going upwards like that, because these are mirror images of each other. So if you have something here, you should have also something over there, you see, because these are supposed to be mirror images of each other based on your line of inverse. So automatically you know that your curve has to be going like that, because if there's an arrow there, there has to be an arrow there, you see. So that's one way you can see, okay, fine, if I have a curve like this one, I have one going like that. If I have a curve downwards like that, I have one going like that. And then these, we know that for our graph of f of x, here we were considering where our x values were bigger or equal to 0, right? That's for the original graph of f of x. Here we were considering where our x values were smaller or equal to 0. That's what we were considering when we were dealing with the original graph. You see, so that's basically the long and short of when you see this. You see, it's just telling you to consider one side of the x-axis. Does that make sense?
Yeah, definitely.
Nice. So let's go through those other questions now. Zoop.